Hi, everyone. Welcome to episode 15 of the Mind Blown Zone. This is part one of a two-part podcast, both titled Material versus Spiritual Reality. So in this episode 15, we'll be speaking specifically about the material reality. And the core question for the podcast is, are material explanations accurate and sufficient to explain our experience, to explain our world? How you doing, Brad?
Beautiful. I have never been better. How about yourself?
Today's a good day. We've recorded already and are about to record some pretty important information. So it's going out into the world, and I'm very satisfied.
Awesome. Totally agree. Take it away.
Okay. So what we're going to be doing is we're going to be putting forward the main material explanations of our experience, right? Which we've identified as Big Bang Theory, theory of evolution, germ theory, theory of universal gravitation, atomic theory, theory of special and general relativity, quantum mechanics theory, and gene theory. Okay, and we'll also touch on magnetism as well. And what we're going to be doing after that is we're going to be pointing out, I suppose, the criticisms. You could even say the damning critiques of these models, where they just don't satisfy, well, I suppose, observation or experience, right? Now, we do want to cover that, as a preface, like before we get into this, we want you to know that, just say we told you this stuff and then you were to go and check it with some expert, right? We want to let you know that they're going to dismiss what we're saying, like out of hand, immediately, unless you've got one of those rare people that's like, I'm happy to listen to anything, but like 95% of the time you're going to get someone that's just like, whoop. And we just want to warn you in advance so that you can check whether this happens or not if they dismiss it for one of these three core reasons, which is Brad and I don't have credentials. Well, what university, Harvard degree do they have? Okay, there's one. Another one is, this is all just ridiculous. This is just stuff that conspiracy theory people say. It's just absurd, right? Okay. And the other one is, well, I mean, we have the math to prove what we're saying. They don't even have math, right? Okay. So if you hear those things, just be aware that those are defenses that are built up around the questioning of these theories. And if you hear those, you might want to press a little harder. How do you like that preface, Brad?
Beautiful. Couldn't have said it better. I was going to call the three things deflections, right? They deflect it away with those excuses. That's all. It's great.
Okay.
That's exactly what we're after.
Yes. So the fundamental picture of reality that we're taught by the mainstream institutions, we go to school, we're taught this. You watch the TV, we're taught this. It's everywhere around you. Everyone's saying it, right? It's all the following materialistic theories, right? So I'll just step through them. We'll take one by one, right? So we got the Big Bang Theory, right? So Big Bang Theory, 13.7 approximately billion years ago, there was a point of zero size and infinite energy that suddenly, for no known reason, suddenly expanded and became the entire universe, right? That's satisfactory, right, Brad? That's the general Big Bang Theory, right?
You can sum it all up by saying everything came from nothing.
Everything came from nothing, right? It contained every single thing in the observable universe, and it just became that from nothing, okay? You want to take theory of evolution, Brad?
Well, of course, the theory of evolution is such. This is, of course, the Darwinian theory that was proposed in the 1850 timeframe, plus or minus 10 or 20 years. And essentially, the idea is that after this Big Bang, everything eventually congealed and water was formed, and then pond scum was formed, and then little cells came together and produced, miniature basic creatures. Eukaryotes, I think, is maybe the first, and then you get some algae and bacteria, and eventually one day all these things, of course, turned into human beings. And that is the essential idea. One thing became another, became another, became another, got more advanced, more intricate, more intelligent. So we started with algae and we ended with humans, all from some random particles mixing together in a little puddle of water. Pretty much sum it up.
Stated. Yep. So then we have germ theory. So this is basically, you know, one of the core reasons why we get sick is because there are little microscopic anti-life things out there that get into us, and they have some sort of agenda somehow, or by random chance, they're programmed to be evil, apparently, against life, and they just cause sickness, right? Little microscopic and even invisible things that we can't see, like viruses, they just make us sick, and that's how we get sick. Happy with that one, Brad?
That's perfect. It's material causing illness. Good story. Cool story, bro, as one of my favorite guys says. I guess I'll do universal gravitation, or gravity. So of course, this is the idea that mass attracts mass. That's what we're all taught in, I think, elementary school. And that there is some substance or force out there in the world that causes, what goes up must come down, as well as holding planets and moons and suns in orbit and on and on and on. So that's the essence of gravity. There's a tremendous force, and it's making all this stuff work the way it works.
Right. Caused by specifically mass.
Just mass. That's all it takes.
So
all it takes.
Atomic theory is at the lowest levels of observation of existence, there are literal things. There literally are protons, neutrons, electrons. Okay, and there's like these three particles. Configurate is perhaps a word, together to form these atoms. Okay, and that's the major body. Of course, below that there's quarks and other, quantum particles, but there's atomic theory.
Right, and those little, the billiard ball theory, as it were, right, forms the elements, that forms the molecules, that forms everything we see.
Right, everything's made of atoms. Yeah,
you can all knock it down to these atoms, which the Greeks theorized many thousands of years ago.
Right. What a coincidence! So they got it perfectly correct.
They got it right. Okay. All these old guys always get it right. Fascinating. All right. I guess I have Einstein stuff. So there's special and general relativity. And I guess I didn't make it clear earlier, but gravity, of course, was proposed by Isaac Newton, the apple falling on the head. Then this guy named Albert Einstein came along right around, I think, 1905 and shook up the world by introducing a new type of gravity that really speaks more to the big picture cosmic gravity. So the relationships between the celestial bodies. And a couple of papers that are widely considered to be some of the most tremendous, intelligent works of all time in the scientific world. Explaining, of course.
And in there is a constant speed of light.
That's one of the things. That's right. Quite a few things we'll talk about in a moment. But yeah, he's able to more accurately explain how the moons and suns and stars and everything, planets all orbit around each other with the use of this theory, relativity.
Right. So then we got quantum mechanics theory. So this is the below atomic theory, that there are quarks and they make up, the protons and the electrons. And I don't know what else to say about that. There are very, 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 very small particles with a whole bunch of stochastic equations and that predict where things will be and how they will be, but it's like there's random chance inputted into the equations that determine it, rather.
Right. And in the immortal words of Richard Feynman, who's a very highly respected scientist and university professor from the 1950s and 60s, he said it's all weird and nonsensical. It doesn't make sense to any of us, but it's right.
Right.
So apparently almost nobody can understand this theory except for people who study it nonstop for 4 or 5 years. And even they think it's beyond bizarre. So but this is a foundational theory, we're told, of how our reality works.
Right.
Yep.
You want to take gene theory?
You're the gene guy. Go ahead. What do we know about genes?
Well, I mean, genes just determine everything, don't they? It's like everything that you become, everything that you experience depends on the genes, right? So the genes are causative, right? So the physical structures cause what you are. I would say that's pretty much it, right?
Yeah, there's some definition of who and what you are. It's immutable, unchangeable, other than if it mutates, of course, but it's something that you're stuck with, and it's already written in stone, and there's nothing you can really do about it. You are at the mercy of your genes. And before you jump onto the next section, do you want to say something else about gene theory?
Yeah, if I could just add on genes, like so, and especially in illness, right? So if you have some lifelong chronic disease or something, well, caused or influenced by genes.
Right? The whole healthcare industry bases a tremendous amount of their suppositions on genes. I just wanted to say it's really important to note, we mentioned it all, but all of these are theories, and the establishment puts out there that they are theories.
Right.
It's really important to understand that none of these are facts. They would take the word theory away from them and say germ fact, or the Big Bang fact, gravity fact. But they haven't done that yet, and hopefully we'll offer a few examples as to why here shortly.
Right. So these are models, right? There are theories and there are models, right? So these are what these are. What the theory itself and the model itself is not reality, right? They are configurations of mathematical concepts and verbal concepts arranged in a way to describe observations of reality that have been made. And whether those observations are correct and factual or not, who knows? But the model seems to indicate that they are to some extent, until you get into the stuff that we're going to talk about in this podcast.
Beautiful. Right. I would just add that, the basis of all of these contains one or more assumptions. Right?
Right.
Somewhere
if you dig down far enough, there are assumptions. Yeah.
Right. That's why they're still theories. All right.
Okay. So do you want to take this? We understand if you accept this, Brett?
Oh, okay. I didn't realize you did the previous section.
I was just going to say that.
Okay. So, the reason we all accept this is because we're under the impression that really, really smart people, and I'm not saying they're not smart, but people went to school and studied this and, got a degree or a master's or a PhD in all these subjects, and they've learned it and fully understand the complexities of what all of us are not expected to understand. And we have no reason to doubt them, it would seem. Right. So this comes from, of course, academia primarily, is where all these anointed intellectual elites are that understand this stuff, that, we're us little plebes can't understand it, don't need to understand it. And of course, it's also pushed by the media, the entertainment industries, movies, and so forth. So they are consistently reminding us of these types of theories as being facts. None of them ever mentioned that these are theories, by the way. In terms of what we get down at the low rung, we're just told this stuff is all beyond questioning and fact. And they remind us that all the degreed experts agree. So it would seem that from, first blush, that there's no reason to question this because all the experts agree. And of course, Matt's favorite line. What's Matt's favorite line?
The math checks out.
It does indeed.
Is that the one?
That is the one.
Yeah, so I'll perhaps mention this one. One of the reasons it makes so much sense to, go, oh, these models are good, is because the math checks out, right? Like if you go do the math and refer to the observations that have been made, it always checks out, right? Like you're not going to be like, wait, this math doesn't even make sense. No, the math checks out, right? So when the math checks out, you're like, oh, okay, so it's right. But just let me give you an example how the math only checks out given the assumptions that were made at the very basis of the model. Okay, so here's an example for cosmology, right? So let's say I assume that the sun shines light on the moon, right? Before people made that assumption, people believed that the moon was a luminary, okay? But let's say I come along and I say, let's assume that the sun shines light on the moon as a very basis of a model. Then let me say that I also assume that the sun is so far away that when light rays come in, they're completely parallel, even if I'm a large distance away from another person on the earth, right? Those are assumptions, but if you start with that, and you also start with, let me assume that the celestial bodies are spheres, all right? You start with those three basic assumptions. You have enough assumptions to now create an entire model with math of the cosmos, okay? Take away those assumptions, though, and let's see you create the model, okay? You're going to have a pretty hard time if you don't start with the assumptions. But you do start with the assumptions, you create a whole bunch of math, and then you can create so much math, and then later, if you come back and check that math, but still keep the assumptions, you're going to be like, the math checks out. But what you got to do is you got to go back to the assumptions and go, how can I know those assumptions are true from the very beginning without any of the math? Good luck. You like that, Brad?
Right. That's perfect. Yeah, and that's what we're up against. And a lot of people really push back hard on this because they need what I call a replacement model. Say, well, if my model isn't right, I want to see your model, and they won't change their position without another model that they can see and build on. And it's a tricky thing for something like sun, moon, stars, Venus, Earth, etc. Right? Who's gonna go out there and show how these things may be different than what we've been told? Right? Nobody apparently can do that. So the model stands,
right, until
that replacement model comes along for some people, in some people's minds,
which is, kind of fair enough, but not completely.
Sure. Well, yeah. I mean, it's fair in that sense that they have this perfect model and they want another one. They're not going to replace it. They need a new model. And the question is, can you survive without a model? Like, what if that's not true? And you just have no model, and they can't for whatever reason.
It's very empowering to let go of the need for a model and just to go back and be like, you know what? Those lights in the sky? What if I just said, I independently, experientially don't know. I'm going to start from right there and see if I can figure it out without blindly believing in authority. That's where we should all be right now.
That'd be a heck of a start. Heck of a start.
Mm-hmm. Cool. I think another thing here is why people believe is that there are, big government agencies, big medical establishment agencies, big scientific agencies, etc., that provide what are supposed to be proof. Just for example, like NASA puts on the website, here are images of, proof, right? And you can look at it and you're like, well, yeah, that looks exactly what I would expect it to look like, So I guess it's real. Did you go yourself and take a photo? No. You've seen an image on a government agency website and gone, yeah, that looks exactly what you said it would look like. Okay, I take it. I believe it. Right.
Right. Exactly. Yeah. And so, right, we've got, all this kind of comes back to some of, our 3 earlier podcasts about, why people believe stuff. And we've got a couple of hurdles to get over, some big ones. Right? One, of course, been mentioned at least once or twice in this podcast, which is blind belief in authority. Assume that the experts are right. We've got belief imprinting, which we talked about at length. And in this example, I mean, we were all exposed to solar systems and mobiles and paintings and books and cartoons with the whole solar system model at a very, very young age. So that was our first image and idea about the lights in the sky were fed to us, age 4, 5, 6. We had all seen it. And lastly, of course, we had this herd mentality thing, which is always ever present, and that you're kind of an outcast if you don't go along with what the establishment and the mainstream folks think is true. Those all get in the way of taking the next steps, which we're pushing towards as we continue.
Right. Okay. So here are, let me just get this right. Here are damning critiques of the 8 core materialistic models that are supposed to explain our realm. So, Big Bang Theory. Now, we want to be clear. We're not saying that these critiques disprove anything, right? We're saying these are damning critiques that need to be fully considered independently and experientially by you, in addition to your consideration of the model. Okay? So with the Big Bang Theory, we have the absurdity of everything coming from nothing, a singularity, a finite point of infinite energy. Like, it is absurd, right? Like, there is no experiential happening or observation that you would be like, yeah, it's that. You would never ever come to that conclusion, right? The only way you can come to that conclusion is by making a whole bunch of cosmological assumptions, like I mentioned before, and then doing a whole bunch of math and like looking at, the things coming from outer space, and then like, oh yeah, it's infinite, yeah, right? Okay, you have to consider that. Now, the second part of it, that makes it even more absurd, is when people are both believe in the Big Bang and are an atheist, right? So imagine not believing in a God, and I'm not stating my belief one way or another. Imagine not believing in a God and also believing in the Big Bang and being like, yes, that's what happened. Okay. So, and Brad's got a point here. Do you want to mention this one in the middle, Brad?
Let me back up. Yeah, let me back up one real quickie here. Matt said at the top of this that we're not trying to disprove anything. I just wanted to add to that it's impossible to disprove something that's never been proven in the first place. Right? It's another thing that gets thrown on our shoulders when we question things. It's like, well, prove it. And so, as I like to say quite often, Maximum's law is, the burden of proof lies on the claimant. So he who makes the claim has to show the proof. And as Matt mentioned, there's no experiment we can do anywhere that shows how you can get something out of nothing. It can't be done in all the physics we can do or experiments we can do on Earth. So why would we then extrapolate that it's something that could happen up in the sky? It's a big, big leap. Yeah.
It's about the biggest leap you could possibly take.
I think it is the biggest of all theories that just completely lacks even a modicum of support.
What's the Big Bang theory?
It is indeed. I mentioned that, one of the things that happens in our universities, of course, is that people who move through these astrophysics courses and everything are people who don't question things. They accept the narrative as true. And the people who, start putting on their critical thinking cap a little bit, thinking about it and questioning and asking, they tend to not make it through the curriculum. They certainly don't get the promotions and the recommendations and so forth, because they're questioning the orthodoxy. Important to understand that.
Okay. Do you want to take a theory of evolution, Brett?
Evolution. I get evolution twice in a row. All right. I guess I will take it. The biggest critique, of course, against the theory of evolution is the absence of transitional species. And the adherents to this theory will say, well, no, here's one between, the 3-legged salamander and the 4-legged salamander or whatever. I just made that up. But there are these very minute examples of, the tailless salamander versus the tailed salamander. And of course, that's not what anybody who's thinking about this more critically. We want to know how a rhinoceros became a giraffe, or, how a bluegill became a whale, right? We need a little bit more, we need a little bit clearer examples of these kind of things. And of course, the missing link, how did, an ape become a human? These are the things that are completely missing from the explanation. And if anything, I think, a lot of people will say, if you look carefully at the archaeological record, you'll see these explosive appearances of, innumerable brand new species. They didn't come gradually. So it's kind of this gradualism versus explosion, and you just don't see that where across a million years, a guppy becomes a frog or whatever the heck they might want to claim. It's just all of a sudden in the fossil record, there's all these brand new things that nobody's ever seen before. So that's a pretty big criticism of the of evolution.
Right.
And
so all you have to do is just imagine like not imagine, start with something like an elephant or a rhinoceros, which is a giraffe, or, just take one of those really funny creatures that isn't really like anything else. And then think, well, what are the things that is supposed to evolve from, right? And then imagine a species halfway between, and then check, has a fossil of that ever been found? Well, no. Okay, no. And it's always no. Now, I floated this idea to a friend, and they said, well, fossils are very hard to find, and they probably just haven't been found yet, but they're probably gonna be found because the theory is right. Okay, and I'm like, and that's sufficient for you to just believe it. Okay.
That's some creative thinking. On a funnier note, I've heard people say, why haven't any of the, chimpanzees or apes, or why haven't they evolved to be more like humans in our lifetimes, right? Like, why are we the only ones that got the evolution? I mean, it's kind of ridiculous to think of it that way, but it's not a bad point. We haven't seen the behavior of chimpanzees, they're evolve in modern times. Like, why is that exactly? Worth mentioning.
Well, why don't you take germ theory, Brad, again, because that's your baby.
Germ theory, yeah. So, I always say this was a reasonable idea at the time. This is the kind of the 1850 to 1900 period where people, started researching and looking into diseases a little bit more often. And, they noticed that when you took the pus or mucus or, bodily fluids or tissues from a sick person, and they looked at the contents under a microscope, they found, these squiggly little microscopic critters, as I like to say. And, these were bacteria. And, they named them collectively. They called these things germs. And they made an assumption here, right, which was that it was the squiggly little critters that they saw that were causing the disease. I'm not saying it was a bad assumption, but it was an assumption. And of course, after the 1900 period, from 1850 to 1900, they're blaming all these diseases on squiggly critters, microscopic critters. And then from 1900 to 1950, they tried to prove that these squiggly critters were the cause of disease and infection. And they had a real hard time with that. In fact, they couldn't do it. Cox postulates were presented, and many, many people attempted to satisfy the postulates with zero success. So we've got basically 100-year period of a theory it's really a refuted hypothesis by that point, and yet here we are 80 years beyond that point, and we're still believing in this thing. What did I say here? Okay. So, and part of that, first 50 years, really almost first 100 years, is they blamed a lot of diseases on the assumption that there were other squiggly little critters that were too small to be seen by their microscopes and technology at the time. These, of course, would be the cooties virus, and that was part of this mix too. So they definitely saw bacteria squiggling around, and that was fair enough that they assumed they were the cause. But they also then, when they couldn't find any of the bacteria, they blamed it on something they couldn't see, the virus. So, just one quick note that nobody has ever found a virus in the fluids or tissues of a sick person to this day. In fact, they pretty much gave up looking for them in the mid-1950s. So no one even tries that anymore. And they say they're too hard to find, or there's not enough there to find. Very suspect and suspicious situation, don't you think?
Oh, yeah. And I would like to mention, if any of the things we're pointing out here, it's, like, hey, what? Huh? What? Huh? Like, we literally, the last podcast we did is purely on viruses. So if you want more information to calm your nerves, just check out the previous podcast.
Right. yeah, that's a hard thing to hear. And I go into quite a bit more detail, which we don't have time in this podcast to do. And I guess we wanted to add here that, yeah, you can go Google picture of virus. You can find 80 billion examples of that. Those are just pictures of, most of those are drawings and CGI, but when you do actually find a real electron microscopic picture, all they're pointing at is some little dots and particles, and they just call them viruses. And that's the end of it, if you can believe it. Hard to believe. Quite true.
And you've written it is a refuted hypothesis. It's been a refuted hypothesis for over a century. It's just refuted by a small group of people, and it's what is the word? Purported or supported or something like that?
Well, yeah, those people are kicked out of or rejected
by a majority.
Academia and the medical institutions, right? So, and of course, finding their books and papers and work is very, very hard. You have to even have the thought that maybe somebody refuted it way back when. And that from there, if you're lucky, you might find one of their papers after a couple months.
And just in case you're worrying, like, well, do you have like another explanation for how people get sick? What are you saying? People don't get sick? We mentioned that in the podcast as well. So it's a wide body of work explaining sickness that doesn't rely on germs.
Right.
Okay.
Right. It's going to take some time for sure. That's the germ theory.
Okay. I'll take universal gravitation. So universal gravitation would be the theory that, the bodies in the sky are solid, massive, well, not necessarily solid, but essentially massive objects, right? And, their movement around is caused by the fact that they have mass and they're attracted to each other, right? And, that extrapolates to Earth, and the Earth is a massive object. We are massive objects, and we are pulled to the Earth. Now, just to be clear, sometimes when I criticize this theory, people say, what are you saying? Gravity doesn't exist? What things don't fall down? Like, no one is saying that things don't fall down, okay? No one is suggesting that there's not some effect where things fall down, right? That's an obvious observable fact. What the thing is the theory suggests that somehow the mass attracts it, right? And they say, oh, well, there must be some sort of graviton. But they don't observe a graviton, right? There is no observation of any graviton. And, this even though they don't observe a graviton, they still theorize that, oh, yes, this massive body, like a bazillion light years away, is like interacting between these two massive objects, right? This graviton at the speed of light and doing it. It's just like, but you don't observe a graviton, right? You're like, no, we haven't seen it. We're still trying to find the graviton. It's like, well, how's it work then? Well, we don't really know how it works yet, but the science is evolving. Science is constantly evolving, and we in the community are really starting to see some breakthrough advances in understanding this, right? They just put on the voice and they're like, wow, science, right? But they don't have any observation of how this works, right? So that's why it's called theory of gravity. Okay.
Most people get away with have the notion that gravity is a force, right? And that a force is a thing, but a force isn't a thing, right? Something makes a force. So there's got to be some thingness involved in the gravitational force. And that's the part they don't want you to think about. Right? What is the cause of the force? So I just want to throw that in there.
Yeah, what's the cause of the force? Now, the experiment, it's tiresome to hear it, but every single person will be like, well, the Cavendish experiment has already proved it, right? Like, man, go have a conversation with ChatGPT-4 about the Cavendish experiment. First of all, ask ChatGPT-4 to devise you an experiment to measure gravity, right? Like, just tell it, I want you to set me up an experiment with a, solid, massive balls hanging from, cables, right? And then I want to have some sort of like device that observes them moving together under the force of gravity. Like, have ChatGPT set up the experiment for you. Watch it suggest that you need some 50,000 kilogram balls next to each other to observe it move a nanometer closer to the other ball in over a period of 24 hours or something like that. I don't know if I'm exaggerating, but like you will look at the experiment and be like, what? And then you go, but hold on, why do we need such an elaborate experiment when Cavendish already did this in the 1700s in his barn with just a few small spheres? How was he able to do it? Well, Cavendish and ChatGPT alone, the Cavendish experiment did this. It's like, but why is it so hard for us to do now? Why can't we repeat that and just watch what happens? Okay, it's a mess, right? And the fact that people quote this thing from 1700s and it's like, okay, well, why don't you go do it? Why don't you go do it yourself and prove to yourself that it's true instead of just, you know, engaging in naive authoritative scientism and just believing that it happened? Why don't you just go do it, right? Oh, I don't have to do it because it's already proven by so many scientists, right? This is a disempowering, lack of intellectual sovereignty and, you know, giving away intellectual sovereignty to scientists whom you've never met and allowing them to tell you what the truth is, right? So just be independent and go do the research yourself, you know, the experiment yourself if you don't believe it.
You'll find that, you know, just to throw it out there, that there's this interesting period of time. You know, I make it from 1830 to 1930, but you can stretch it back to 1797 or, you know, 1780 or whatever. But there's this period of time when all these tremendous experiments were done that give us the supposed proofs of what reality is and how it works. And they're so definitive that we're told no one needs to recreate them because they've already been done, which is a fascinating story to tell, is it not? Considering the advances in technology from 1797 to today. By the way, I also think that I just remember from the ChatGPT thing we're doing, I think the spheres had a radius of 47 kilometers. Wasn't that right?
Oh, yeah. I think it might have been a 47-kilometer diameter
Osmium sphere.
Osmium, a 22,000 kilogram per, you know, density kind of thing, or whatever, you know.
Right. You know,
23
that's
times the density of water, basically.
For the English people in the room, you know, that's like a 25-mile long ball of osmium. Ridiculous, right?
So all you need to do is tab over to ChatGPT, right? You can do it right now. Just go talk to it. Check it yourself. You want to do atomic theory?
I would love to do atomic theory. So, and my first comment about this too is that, you know, the idea of atoms, neutrons, protons, and electrons is a very useful tool, a useful model for modeling things that happen. It's kind of like, it's the same as Matt was saying earlier. We're not denying that there's a gravitational effect, right? That things fall down, or things that go up come down. We don't deny that. Just like the atomic model, the theory, we agree that it's a useful model for explaining why chemicals come together or why, you know, electrical charges and discharges happen. No question about it. The question is, right, are we really living in the billiard ball world where it's just ricocheting particles and balls, and that explains our reality? And this is what, of course, the establishment would like us to believe. But when you start digging into this, of course, you'll find out that no one's ever taken a picture of or a video of an atom, right? You can't see this setup. And, you know, Matt made a good point that the nucleus is so much bigger than the orbiting electrons and protons and so forth that you can't get them both in the same picture and say, okay, well, that's fine, but can you just give me a picture of the orbiting electrons and protons? And I guess you asked ChatGPT this as well, and they said, sorry, can't get a picture. For who knows what reason. But the point is that until we get a picture, we're working with yet another theory out there. Just because the math and the models work doesn't mean it actually really represents reality. And that's the whole point of this podcast.
Right. So something I don't like is that when people talk, they're like an electron. They just say it, you know, a proton, a neutron. They just say it. And they think that they're referring literally directly to reality, not a model. Right. And I've scolded ChatGPT for. I'm like, why do you present these things as if you're just literally talking about reality? Why don't you say according to this model and the way we describe reality? But there, it's just like, now that's it. That's the thing. Have you ever observed it? Well, I haven't observed it. The scientists observe it. That's how it is. Right? This is basically called naive scientific realism. Okay. All right.
Bingo. Take it away. You're on relativity. Yeah, you want me to do it?
You go into this one. You're more familiar, I'd say.
Gotcha. So, of course, this is the Einsteinian, Wonder Kid papers that he put out, and it's important to note that there were a lot of other smart guys studying, physics and cosmology and electronics and all these types of things right alongside him at the time. And in Einstein's papers, he doesn't give anybody else credit, and yet it's clear that he stole many of the equations and ideas from his contemporaries and people before him, right? The Lorentz transformations and the work of Henri Poincaré and several others as well. So he's not the amazing, he didn't amazingly come up with these ideas in the back of the patent office one day when he was daydreaming, as we've been told. But so part of what Einstein did was, in one fell swoop, he eliminated what a lot of smart scientists at the time believed, that there was what they called an ether out there, and that was basically a medium, right? Like water is the ether for fish, right? Like we swim in this ether of air, but you're talking about this ether that encompassed everything, and this allowed them to talk about waves, of course. And the only way you can have waves is if there's a medium for things to move through. And this was, of course, how they explained things like light. And Einstein eliminates it. And he then postulates for the first time another billiard ball in the mix, and he named that a photon. So he described what light is: photons. So the particles coming from the sun, for example.
Right.
And furthermore, it propagated through nothing, right? So if Matt and I were standing in a vacuum, other than the fact that our heads would explode or whatever they say would happen, we couldn't talk to each other because there's no air molecule, there's no oxygen and hydrogen and carbon molecules in the air to carry my voice to him. We need that medium. And in the same way, the light from the sun needs a medium to travel from the sun to the earth. This was the leading idea, and before Einstein came along, he wiped it all out. He created a vacuum, so a space where there's nothing, it's empty, and he created the photon in one fell swoop. Radical ideas that to this day, once again, no proof. There's no proof that a photon exists, and nobody can prove that space is empty. Can't be done. So we're forced to believe in this theory based on some of these assumptions.
Right. And I wanted to acknowledge something, because, in quantum field theory, for example, you don't have a literal vacuum with nothing. You have, fields that are at non-zero energy levels everywhere, right? However, just remember, that is a separate theory, right?
Right.
So that is literally a separate theory. And, to have your theory where there is nothing, like in the Einsteinian general relativity, there is nothing, right? So that's a model explaining things in an absurd way, right? Okay, you can point to something and say, okay, there's another theory that has it, but that's a different theory, okay? So that doesn't support the Einsteinian theory, okay? Right. And the other thing is, we know we're just covering things and casting shade and stuff. I just want to remind you, we're not pretending like we're disproving this stuff. We're just saying that, the absurdity of these things has to be fully considered by each individual. All right.
And I'll remind Matt that we can't disprove something that hasn't been proven yet. Bada bing. Right. I zinged you there. So yeah.
And so if I can just mention this dark energy thing.
Oh, I was
already known, but you wanted to go for it. It looks so appealing. It's so juicy. You can have it there.
So now we've got this vacuum, and then we've got this QFT theory, and now we run into a problem very shortly after, 20, 30 years after Einstein's theory. We have mathematicians, they're looking at the lights in the sky, and they start trying to do the math and realize that this doesn't make any sense and that gravity doesn't work because these things are too big, these things are too small, these things are moving too fast, these are too slow. So gravity doesn't work for any of it. So real quickly, they have to invent two more new things. They have to invent dark matter and dark energy to uphold Einstein gravitation. And these are two substances that nobody can detect, right? They're undetectable. No one knows what they are, but they make up 95% of our universe. 95%. And we can't detect them. And now...
It is all true.
Now that we do. Right? So now we've got a vacuum in it, but it can't be a vacuum because it's got gravitons and photons and dark energy and dark matter all inside of it. So which is it? Is it a gravity, or does it have all this stuff, or is it a vacuum, or does it have all these things floating around in it? Got to be one or the other, right?
Right. So, I mean, it's already known. General relativity does not describe the universe. Like, it breaks down, and then you need to invent, well, how do we explain it then? Okay, more math, right? Well, let's suppose that there's a dark matter. Let's suppose that there's a dark energy assumption. And, how would the math work for that? You just invent a whole bunch of math, right? So that's what you need to understand and consider, that these models are just continuations of expanding, failing math time after time. And, then it gets all put on PBS Spacetime or whatever, and the guy's like, scientists may have discovered the very nature of our universe. And it's like, it's made up, okay? It's made up. We understand that these things model reality, right? But stop believing that it's actually like that, right? Stop that.
If you were just to wipe out gravity, you could wipe out all the rest of this stuff in one fell swoop.
Right.
A thing that's never been proven to exist. That's all it takes.
Yeah.
Yeah. So I guess we added this, the grand unified theories, of course, of what scientists and physicists have allegedly been working on for the last 100-odd years to unify quantum mechanics and relativity. And no one's gotten any closer than the first guy who started. Just gotten more complicated. Right. There's a lot of other critiques of, a relativity. There's the clock paradox. There's the, I forget the name of it, but there's the Cartesian, or there's the point. I can't remember. I never remember the name of it, but when you read it and really think about it, Einstein's kind of inventing these scenarios that are, of course, they're kind of impossible to prove, or either that, or they give us two different answers, depending on which frame of reference you're in the Einsteinian model. Well, then that begs the question: well, which one's the right answer? If you get two different answers, which one's the right answer? And there's just one after another of these paradoxes when you read it, and to just accept it as truth, as so many people try to pass off, is the astonishing part of it all, because none of these things have been resolved. And I'll do this last bit here only because I do this with Matt all the time, and a lot of people, want to be clear with people that we're not questioning math. Right? We all agree that 2 + 2 = 4, and nobody's questioning that. That works. Mathematics works. But E = mc², right? Which people say that's math. It works. Has an assumption built into it, right? It has an assumption that light has a speed that nobody can really measure. I know there's one thing from 1925 or something where some guys allegedly pulled it off by sheer luck. But other than those guys from 100 years ago, nobody can measure it anymore for some strange reason. Could it be because light doesn't have a speed? Is that a possibility? That is the real question that we're throwing out there. Is that, we see illumination has a speed, right? Like when our eyes finally see the illumination, but is that light photons traveling between point A and point B? That's the question. And just yet another thing that breaks down Einsteinian relativity. We toss out one of these assumptions in these famous math equations. So the math checks out. What's next?
if I can
Or do
just
you
cast a
want to
little
add?
shade on the speed of light, because there are experiments that supposedly, show the speed of light. But one of them is this like rotating octagon that I can't go too deep into it. You'll just have to look it up, and they shine light. It bounces on this octagon, and it sends the light over that way. 20 kilometers down that way, and then gets bounced back, and it hits this other part of the octagon, and goes down and hits that. And by some math, and then all the math checks out. It indicates that that it only hits perfectly when the octagon is rotating at a specific speed, right? A certain number of revolutions per second, right? So they're like, yeah, we got that. And then we got resonance, right? So we can see that, yeah, but by our calculations, it shows, right? So you can look up that thing. It's it's a Michelson. I think it was that guy Michelson that did it. It's not Michelson-Morley. It's a different thing. It's a Michelson speed of light experiment. Just look it up. But the fundamental thing in that is that the frequency at which this thing is rotating is 520 hertz. And if you look up 520 hertz, you find that it's the frequency in the solfeggio scale, the Gregorian chant kind of stuff of love, right? It's the frequency that John Lennon recorded Imagine in. Hey, you tell someone to that who believes in all this stuff, and they'll say, well, that's just a coincidence. Yeah, but what you find is you present all these things one after the other, and well, that's a coincidence, that's a coincidence, that's a coincidence. So just imagine the immensity of the coincidence that a thing that measures the speed of light requires that a thing be rotating at the exact frequency of what is considered in people in spiritual realms, like spiritual ideologies, let's say, to be the frequency of love. Whoa. I mean, what a coincidence, right?
Just
a little bit of shade on the speed of light there.
Right on.
Quantum mechanics?
You're next. Knock it out.
Okay, so I haven't verified this myself, but Brad, you told me this. Apparently, even Richard Feynman, I used to love Richard Feynman, and I still do. I like Richard Feynman.
Sure,
great guy, and I learned a lot of mathematics from him, in science. He's the idol of the scientism world in a way. He's admitted that no one can understand quantum field theory, right? And you might say, oh, the smart scientists, of course they understand it. But here's the thing. Regular people don't, right? And to be a regular person who hasn't studied it at all, but accept the conclusions of it, is naive authoritative scientism, okay? So you have to realize that quantum particles, do you know how small these things are supposed to be? They haven't been observed, right? You can't get a photograph of a quantum particle, right? They can only infer. They're like, we blasted this thing. Go on, brother.
I was going to say, but what did they do at CERN then for all those hundreds of billions of dollars they spent?
Yeah, right. Yeah, sure. Let's not get into that. But they crash neutrinos at the speed of light, into things, and then they have a squiggle on the diagram, and they're like, this is the excitation of a particle in the quantum field. And they're like, therefore, according to the math that we invented that predicted this thing, it all checks out, right? Our observations are correct again, right? They're not observing quantum particles, right? So don't have in your head quantum particles exist, right? You can have this model. We're not disputing that the model predicts observations or anything like that. We 100% agree, but don't have in your head quantum particles exist, okay? You want to take these other things, Brad? I'm not too familiar.
Oh, okay. Well, there's
other thing you mentioned here.
Quantum state superposition is the whole premise of, the quantum computers and so forth. Basically, the idea, of course, is that there's a particle can be two places at the same time. It might be here, might be there. It's kind of akin to the idea that everything can come from nothing. We have no examples of how this could possibly be true. And it's frankly, from my perspective, it's an absurdity that this is true. And of course, they love to talk about the wave particle duality, and that sometimes it is, if you look at it, it's a particle. If you don't look at it, it's a wave. So how can we know that, they've got the Dr. Quantum experiment and cartoon people may have seen? It's not even close to being correct in how things were done. They pretend like they've got this cannon shooting electrons one at a time through these the double slit experiment. And of course, no one's ever seen an electron. So how in the world are they shooting electrons through, a double slit? Right? Begs the question again and again, what's going on here? So
They didn't grab an electron and put the electron somewhere and then, fire the electron, right?
Yeah, like they got a bucket of electrons and they're just sucking them out of there and shooting them through their cannon at the double slit. Right? That's your takeaway from watching that experiment. And so
must have got a bucket of electrons and fired them off one after the other. That's hilarious,
right? That's the picture you have, like a bucket of ping pong balls or something. They're just shooting through the cannon, and they're if you look at it, it goes this way, and if you don't look at it, it goes this way, right? You get the field effect, the wave effect if you're not looking at it, the particle effect if you are looking at it. I mean, it begs the question, what's really happening here, and what are they really talking about? But again, that's a consumerish cartoon for us low level guys. So that's quantum theory.
We're not saying, if I can just mention, Brad, we're not saying that the experiment. We're not saying that the experiment didn't happen. We're not saying that the observations weren't made. We're not saying that this doesn't model reality, right? But what they're doing is they take observations and then they invent a bunch of math and a bunch of concepts, right? It's all rationalism, right? Electron is a concept, right? It's not an existent. It's a concept to stand in for
an assumption.
Reality.
Yeah,
right.
It is.
And they're like, yeah, I mean, when I put the math and the concepts in this configuration, it explains it. But don't be confused between the conceptual explanation and the reality.
The short version of it is, if it isn't a bunch of billiard balls bouncing around like we've been taught, which is the materialist viewpoint, then something else is happening that has not been described in our mainstream academic science. That's what we're getting at.
Right. Yeah. Did you want to mention magnetism here?
Just real quick, this is something that Matt and I haven't looked at closely enough yet, so we can't elaborate on it. But there's an interesting guy out there. He's got a YouTube channel. It's called Theoria Apophasis. His name's Ken Wheeler, and he's a really bright guy. I listen to him quite a bit, and he's got a bunch of amazing perspectives on all the things we talked about here tonight. And he goes way deeper and further than anything we touched on. But he's also claims that he's written a paper that basically upends what magnetism is and how it works and what's really happening. And it requires a certain level of understanding and knowledge that I don't know that I have. Matt certainly has it, but it takes some time to read it, think about it, understand what he's saying, because he's really upending the entire model of magnetism. So I wanted to include that tonight just because we're talking about basically the fundamental building blocks of our reality and what's being taught to us and what assumptions are being made and what things can't be proven. And perhaps, just perhaps, there's some other explanations out there. So I wanted to toss that in there.
Right. Yeah, I mean, what we intend to do is we'll live stream a session where we sit down and look at this guy's paper, and we'll have ChatGPT 4 going as well, or 5 if it's out at that time, and I'll have a tablet and a stylus, and we'll just go through it, right? And people can actually watch it happen.
Sounds like fun. What do you know about genes?
Well, okay, first on the genes, we have to clarify that genes have some basis in reality, right? You could this genetic idea, you can observe that you come out kind of looking like your siblings and your parents and stuff like that, right? So this is kind of there must be some sort of thing somewhere that's causing this. We must get something from the parents, right? And if you look at the genes in the child and the parents, you're like, yeah, check it out. They get the same genes, right? Imagine that. Okay, so, but what's going on is that this theory is being used to explain diseases, right? So we want to cast some shade on that a bit, right? This is your quote, Brad. Do you want to just put this forward as a pretty cool tidbit? It's not Brad's quote. It's Brad introduced this quote. So why don't you read this out, Brad?
Yeah, I'm not going to read the exact quote, but the point is that, and this was pointed out by Stefan Malaka, that there a group of the 25 leading geneticists sat down at Cal Berkeley back in 2006, I think, and spent a
It was
weekend.
Craig Winter who said this, just to be clear.
Craig Winter,
who wrote about this thing.
Effectively, they were trying to come into agreement on a number of different subjects, and they ended the meeting all angry at each other, screaming and yelling. And as it turns out, they all couldn't even agree on what a gene actually was. If you can almost believe that.
That's hilarious.
These are the world's leading genetic experts, and believe me, and by 2006 we are far down the path of genetics, right? I mean, this started, really taking off in the late 80s, and huge advances in the 90s. So we're 20 years into this study of this topic, and the experts can't agree on what a gene really is. So I thought that was pretty doggone interesting, that something like that could actually happen not so long ago. But you were talking about diseases, and I thought you were going to touch on. We had a little fun with ChatGPT the other night when you were poking at it. I mentioned Huntington's disease, and sure enough, ChatGPT just jumped right out of the gate saying how that was, a well-established genetic disorder, right? And I had Matt press it a little bit and ask it some questions. And basically my question was, based on, if one parent has it, then the child has a 50% chance, yada, yada, yada. And we asked ChatGPT, with a newborn baby, can you test it and determine whether or not it's going to have Huntington's disease in its life, right? Because it's allegedly, it either got the gene or didn't get the gene from the parent. And ChatGPT had to, ashamedly admit that no such thing had ever been done before.
Right. Can I just re-explain that just to add some clarity? So, the assumption might be that, a geneticist or whatever are testing, children when they're young, checking their genes, and then making a prediction whether they'll get this disease or not in the future, right? You would think that's happening, right? Like, for example, something like Huntington's, you'd be like, yeah, I mean, they know it so well, they must be able to predict, right? Because I asked ChatGPT, and they said, yeah, we can predict it. Yeah, it's predictable. And I was like, okay, well, let me just check with you. Are you saying that there has been a specific study where they literally went and looked at their genes and then checked with them, early in life, and then checked with them later in life and checked? Did that happen? No. And it said, as of my knowledge cutoff in September 2021, I do not have access to a specific publicly available case study where genetic testing was conducted on a baby to check for Huntington's gene, right? It's not happening, right? All they're doing is later, when someone gets the disease, they're checking the genes then and going, yes, they got the gene. But here's the thing, they don't always have the gene, right? So I've done this other thing. There's an FAT gene, right? Imagine they call it the fat gene. It's a gene that they correlate with being overweight, right? And the thing is, sometimes people with the gene are overweight, and sometimes people with the gene are not overweight. And sometimes people without the gene are overweight, and sometimes people without the gene are not overweight, right? So there's a correlation. But if you were to, the thing that they're trying to say is that, these genes cause things. Like, how can you have a gene just be correlated with something? I mean, it's absurd, right? So the models, when you press them, you just find that these gene models, they just break down. All they're observing is correlations between diseases and genes. And then they're assigning causation to the genes. And people are like, oh yeah, I'm that way because of my genes, right? You'll hear people say this. They say it's because of my genes. And it's not because of your genes, right? You don't know what your genes are. You've not gone and tested your genes. Your doctor's telling it could be because of your genes, because apparently out there people have done trials and confirmed stuff, but they're just doing correlation, and that's it. Okay, I have a theory that it's just a theory. You can critique it, you can say it's stupid all you want. It's literally just a theory that I would be interested in testing in the future. But my theory is that your genes are your physical manifestation of your beliefs. Okay, I won't say anything more on that, but that's just a theory I have. Anything you want to add, Brad?
I was just going to say, let's not forget that the 25 leading experts couldn't even agree on what a gene was about 15 years ago.
Oh, you didn't get to that part? I'm sorry.
No,
That was
I'm
key.
just
I thought
reminding.
you'd already said it.
I said it. I'm just saying,
Right.
after all of that
Right,
talk,
right,
you've
right.
got the fat gene, you've got the Huntington's gene, but we don't even know what a gene is,
They didn't even
apparently.
know what a gene is, right?
They certainly
And
can't
you would
agree on it.
assume, oh, but that was in 2006. I mean, like, surely the science has evolved. I mean, science is constantly evolving. It's like, yeah, but people would have believed this exact stuff in 2005, right? I could have made this exact talk in 2005, right? And people had the exact same beliefs about genes back then, right? So it's not a case of, oh, the science has evolved and stuff like this. It's just that you have to stop having this naive authoritative scientism view of the world where you're just like, oh, the scientific experts said it, that's way. I mean, they're really smart and they've said it. It's like, dig into it. Just dig into it, question it more, okay?
You want me to do this? Yeah. So this, I think I threw this in here at the tail end of this, but Francis Watson or Watson Crick or whatever, these Watson and Crick guys who allegedly discovered DNA, 1950s, right? They won a Nobel Prize for their discovery of DNA, and they had the beautiful double helix spiraling picture of this, majestic looking piece of machinery. And as it turns out, these guys never saw anything like that. And one of their wives actually drew a pretty picture and they liked it. And so they assigned it to, this is what DNA looks like. And to this day, I believe there's only one person who's claimed that they've got a picture of DNA. You can almost believe that. And that was from 2012. So, 60 years after the Watson and Crick discovery, this is the first time we actually see the double helix structure of DNA, allegedly. But so far, we've only got one actual electron microscope picture. So what is that? Where does that leave you? Does that leave you pretty confident that it's all been settled and is this just another case where the guys theorized it, kind of pretended like they saw it, but didn't really, and then their beliefs were confirmed 60 years later? Is that another one of these? What do you think?
I guess suspicious that it could be. Independent research should be advised.
Nobody else has gotten a picture in the last 11 years, apparently. So apparently this DNA thing that we've all reminded of constantly, mRNA, DNA, et cetera, is a pretty elusive little bugger, kind of like an atom and a photon and a graviton, 57,000 other things out there. We're just throwing it out there. That's pretty strange, isn't it?
Mm-hmm. I mean, I love it as a model. It's a great model. I love modeling. When I did university, that's what the thing I loved the most, modeling reality. I would do models of, computer models of planes and helicopters and helicopter blades.
Right.
And it was fascinating, right? And it models reality. I mean, it predicts how a helicopter is going to fly, right? But the computer program and the math that I wrote is literally just a model. And if you ask me, does that model actually refer to how it works? I'd be like, no, it's just a silly model that I made up that works really well.
Right. Well, I think that's a good way to kind of close out here, is that we have been sort of indoctrinated into fusing models with reality and accepting those models as our picture of reality.
Right.
And clearly, there are many, many flaws in all these explanations, such that to just blindly believe they're true, right, is, a big mistake. And it leads to other mistakes that lead to other mistakes and flaws. As the pithy saying goes, right, the truth will set you free. So my little theory, which I'm not going to delve into at all, but this idea that the more lies we believe, the further we are from the truth, the less free we are. So in a sense, all of this stuff that we've talked about tonight is, in a way, a method to entrap or ensnare us or enslave us into this false vision of reality, and keep us at a minimum confused, and in many cases just completely ignorant of what we're surrounded by.
Okay, so what we recommend is that, take these ideas to some scientists that and go in honor and go with respect and present them to them. And also ask them, and see what they say, and ask them if when they're communicating their idea that they're, aware that what they're saying is just a model, or whether they argue that it's the exact underlying reality. Okay, that's an interesting point to present to them. And just secondary instructions for when you communicate about these models. Stop, I suppose the right word is pretending. Stop pretending that, you're referring to reality, right? Just say, for example, according to the theory of this, according to the Big Bang, when this happened, according to gravity theory, according to atomic theory, just be clear on that, okay? Just have this awareness in the back of your head that the model is not the reality, okay? Anything you want to add, Brad, before I mention take your power back?
No, I think that's some good advice, right? It's just coming down to reevaluating what's really going on and how much truth we've been told. Those are the questions that need to be examined, for sure.
Right. And I suppose we could even just touch on, the key word of this at the beginning was materialism, right? So all these models that we've presented to you are materialism, right? It's considering that every single thing in the universe is matter, right? Yeah, according to all this materialist science, even your consciousness, your soul, it's all just a chance configuration of atoms, quantum particles, just that have just turned out that way. And evolution, it's all chance of how these molecules interacted in chemical equations that turned out this way. And all the Big Bang is just like, the theory of matter, how did matter progress, according to this rocky theory where you have to introduce dark matter and dark energy, okay? So, we have this course that we always mention at the end of the podcast. It's called Take Your Power Back. And Take Your Power Back is a course that empowers you, in every sense of the word, all right? Because one of the things that we're referring to in this podcast is this delegation of intellectual sovereignty, right? We're living under, like almost everyone in the world is living under what I'm calling at this time, naive authoritative scientism, right? Where there's just all these beliefs about science, right? That come from the authorities, and we naively, which doesn't mean stupidly, it just means naively, just like, oh yeah, that's what it is, just take it at face value, sure. Yeah, just believe what the authorities say are the conclusions of science, just accept it, right? And we just operate like that's the reality without any critical analysis, right? So the scientism implies that there's not really any real critical analysis or real experiential knowing going on, just beliefs about science, right? At the level of the believer, most of us, right? So Take Your Power Back helps you to become an individual that has the courage to look directly at reality and use your own experiential knowledge and know for yourself. And this has wide applications in all of your life. It's not just in knowing science or something like that. It's it fully connects you to reality, right? It changes it from reality being like loosely perceived around here and like inferred and stuff like that, to where you're truly living and connected with reality. That's just one facet of it. And you can find out more on themindblownzone.com exactly what it is. Do you want to add something about Take Your Power Back, right, in this context?
Well, yeah, just, maybe overall the podcast itself, as well as Take Your Power Back. And, that, I mentioned at the top, I don't think we mentioned it here at the end, is that we're going to have a part 2 to this, which is going to be looking at a spiritual reality. And these are really the two things that are coming into conflict here. Is this materialist explanation of reality accurate or not? And if it's not, then as hopefully we've pointed to a few major flaws and assumptions in it, then why would you reject looking at the spiritual explanation of reality? It's certainly a second explanation, and it may not have mathematical precision or scientifically provable facts, but a lot of what is going on around here. You know, we aren't meant to know everything. If we were, it would have been explained to us by now. So some things are never going to be, you can't put them in this convenient little box of bouncing billiard balls and flying saucers and everything else that is explained in reality. So part of the Take Your Power Back course that goes along with this is this idea that, you know, it's the letting go. And it's my assertion, and we'll get into this certainly many more times in future podcasts, that, you know, I'm really asserting that, you know, your opportunity to be set free by knowing the truth is a whole heck of a lot less as a part of learning new things and understanding new things and new intellectual knowledge. That's not really what's going to set you free. It's letting go of these things that have been passed around as reality all our lives. And we've been told this is how it works and this is the way things are. And letting go a lot of that stuff is really a path forward in your empowerment. And we'll obviously get into that a little bit more in the second podcast. It has the spiritual reality aspect of things. And you'll get a much, much deeper taste of that in the Take Your Power Back course, which is what it's really based on.
Mm-hmm. Right. I'll just mention one more thing, which is that, you know, it might seem like the purpose of this podcast was just to like criticize science. It's not really that. It's just to point out that, you know, these are the 8 major models, and, you know, there are just examples of the way we are interacting with science in this naive, authoritative scientism way. And when you just believe it like this, I mean, yeah, it's okay. Quantum theory, what are the implications for your life? Pretty much nothing, right? But like when it comes down to your health and your life, you know, people are stressed, they're anxious, they're having diseases, right? That's where it really matters, right? And if you're, you know, taking all these scientific models and stuff like that and trying to improve your health and stuff like that, oh my gosh, like materialistic approach to health, oh, get ready for decades of struggle, right? It's only once you let go of this materialistic stuff that you actually get real results that you're looking for, okay? So it's really important to your life that you step back from this a little bit.
Yeah, and you could almost pitch then the conscious eating, which is not necessarily health. I mean, it is related to health, but obviously weight loss and you know, fitness and things.
Right.
Certainly add to your health, and it's also got this spiritual grounding in it as well.
Yeah, right. There's 2 other courses that we have at the moment. One's the Back Pain Miracle, and one's the Conscious Eating, the Key to Weight Loss. So if your specific problems that you're facing are back pain or weight, we have it. Okay, mindblowenzone.com. I'm sorry, themindblowenzone.com. It's there, right? Physical pain, weight loss, we have it. Okay. I understand that everyone's engaging a materialistic thing and calories in, calories out, and trying to force diet and suppress cravings and stuff like that. Just look at the state of the world that has arisen based on those principles. It doesn't work, okay? You have to go into the emotions. You have to go deeper into consciousness to solve these issues and get what you want in life, okay? And health. So we've got it, the Back Pain Miracle and Conscious Eating, the Key to Weight Loss at themindblowenzone.com. Enjoy.
Awesome. Yeah. So look forward to part 2. We'll discuss some other possibilities for what reality is based on, and give everybody an opportunity to weigh those against the materialist ones, and we'll take it from there. Good
All right.
night, Matt. Anything else you'd like to add?
No, that's everything.
Right on. All right. Well, thanks everybody. Thanks, Matt, for joining, and we will see you in the next podcast or at themindblowenzone.com. Thanks, Matt.
All right. Thanks, Brad. Thanks, everyone. Have a good one. Bye.
Bye-bye.